This video will deal with functions, domains, and ranges. Before we can talk about any of the three, however, we must first talk about relations. A relation is nothing more than one set of data related to another set of data. For instance, let's say set A is a list of first names. Set B could be a list of last names. Obviously, we who are fans of Harry Potter knows the relationships. We call a relation a function when there's one and only one possible set B result for every set A entry. For instance, for Harry, there is only one possible last name, Potter. For Ron, there is only one possible last name, Weasley. Hermione is Granger, Luna is Lovegood, Severus is Snape, Ginny is Weasley, just like Ron. However, it's okay that there is more than one set A that has a particular set B result. All we need to make sure is that each set A has only one possible result from set B. Each one of the characters in set A, the first names, has one and only one last name associated with them. Neville with Longbottom and Draco with Malfoy. That is a function when each has only one possible result, like so. Looking at the relation the opposite direction, however, would not be considered a function. If we're asking for last names, whose last name is Potter, we still have one and only one person, that's Harry. Whose last name is Granger? There's only one person, Hermione. Whose last name is Lovegood? Luna. Whose last name is Snape? Severus. Whose last name is Longbottom? Neville. Whose last name is Malfoy? Draco. But when we get to asking whose last name is Weasley, now we don't have just one possible answer. We have Ron or Ginny. That makes it no longer a function. A function always has one answer for every question. No more than one. No less than one. One answer for every question. So from A to B, it was a function. Every first name had one and only one possible last name. But the other direction is not a function. Every last name was not able to match up perfectly. We had two first names associated with the same last name. So that is no longer a function. Instead of the phrases set A and set B, you'll usually see the words domain and range. This is just a standardized way of referring to the two different sets of data that are related to each other. The domain would be the questions. For instance, we asked, if this is somebody's first name, what is their last name? And their last name would be the answer, which was in the range. So the domain is what you're asking about. The range is the results you're getting. When there were no duplicates in the domain, the relation is considered a function. You will often see domains and ranges listed like this. The symbol indicating a set is the bracer right here. It often reminds me of Bob Hope. That's how I can remember how to do the bracers. We've got a great big forehead over here, a really pointy nose, and a great big chin. So we had the bracers, and then we list the domain, and we list the range. The order within the set is irrelevant. You can put them in alphabetical order if you want. You can put them in the order that they're used. If they were numbers, you could put them in numeric order. The order is irrelevant. What matters is that you list the domain and list the range. Now, when we were asking about the first names, what is the last name of Harry, then we were getting Potter. Remember, the domain is the question and the range is the answer. When there were no duplicates in the domain, we're not having any of these show up twice in the domain. It is a function. It's okay that Weasley shows up twice in the range. I spelled Weasley wrong there. It's okay that Weasley shows up twice in the range. That doesn't matter. What matters is that there's nothing duplicated in the domain. That's the important part. So therefore, this is a function. It is still a relation, but now we can specifically refer to it as a function because there is no duplicate in the domain. Okay, when we reverse the question, then the last names become the domain and the first names become the range. Remember, we said, well, what if we asked it the other way? Whose last name is Potter? Well, that would be Harry. Whose last name is Granger? That's Hermione. Last name is Lovegood. That's Luna. Last name is Snape. That's Severus. Last name is Malfoy. That's Draco. Last name is Longbottom. That's Neville. So far, we've only had one answer every time we've asked a question. Remember, the question is the domain. The range is the answer. Every time we've asked a question, we've only had one possible answer. However, when we say whose last name is Weasley, we could have either Ron or Ginny. And notice that Weasley is listed twice in the domain because in order to get to the range, Ron and Ginny, we had to have, in order to get to the two answers, we had to have two questions. But those questions are the same, aren't they? When we ask whose last name is Weasley, it could be Ron or Ginny. Remember, order doesn't matter. We can't say, well, this is Ron's Weasley and this is Ginny's Weasley. If we were to say, what boy has the last name Weasley, what girl has the last name Weasley, then we only have one answer again, but that's not the question. The question is, whose last name is Weasley? There's two possible answers for that, so this is not a function. It's still a relation. Those sets of data are related to each other, but it is not considered a function. The function's data can also be listed like this. These are what's called ordered pairs. It's not ordered in the sense that they are in any particular order, as in oldest to youngest or alphabetical or anything like that. They're ordered in the sense that the domain is given first, then the range is given second. So in this case, the domain is the first names, the range is the last names. When it's numerical and we can put them on graphs, a lot of times you'll see it as X and Y. Same thing. Now it's just easier to deal with because we have numbers involved instead of names and words and phrases and such. But a function can be anything. A relation can be anything. Domain and range can be anything. But we're used to dealing with numerical values. So a lot of times we have the X and the Y, but it's the same as the domain and the range. Now, how do we remember which comes first? Domain or range? X or Y? These are ordered alphabetically. D comes before R, so domain comes before range. X becomes before Y, so X comes so X comes before Y. It's alphabetical. So that's the order in an ordered pair, is the domain before the range, X before the Y. And if you're given a set of ordered pairs, then you can find the domain and range because you know that the domain comes first. So if they said, what's the domain of this set of ordered pair? You would just pick all these first values, and you would say the domain is Ron, Harry, Hermione, Luna, Draco, Severus, Neville, and Ginny. That's the domain. And then if they said, well, what's the range? You could say, well, the range is Weasley, Potter, Granger, Lovegood, Malfoy, Snape, Longbottom, and Weasley. That's simple. That's domain and range of a function. And a function is a relation where there's no duplicates in the domain. The other way to recognize a function if it's given to you graphically is with what's called the vertical line test. Here on this graph I have 4 different functions. Doesn't matter what kind of function it is, the vertical line test works the same way. If you were to draw a vertical line anywhere on that graph, the question you have to ask yourself is it going to hit the function more than once? So let's draw a whole bunch of vertical lines and see if at any point the vertical line hits the graph more than once. All these red lines should be vertical. Okay, so let's look at the blue function first. The blue function hits this vertical line once. Never does the blue graph get contacted with the vertical line more than once. So the blue line is a function. The brown one also contacts vertical lines only once each. That is a function. The green one, however, if we look at the green one here, this vertical line is hitting it more than once. These vertical lines don't touch the green graph at all. Okay? And that's okay. The problem is that it does hit more than once. If at any time a vertical line hits a graph more than once, it is not a function. So the green graph is not a function. The blue one is a function. The brown one is a function. But the green one is not. Now the purple one looks a little strange, probably. You probably haven't seen very many graphs like the purple one. The purple one is what's called a stepped graph. And what it means is, what this circle over here on the end means is that the line goes from here to as close as it can get to here, but not quite getting there. It doesn't exist at this point. It does exist here. And then it goes as close as it can, but doesn't actually get there. And then it goes right here and here and here. So if we look, it's only hitting once. But look here. It goes through the circle and touches the graph at that point right there. Is this a function? Yes, because remember, the circle means it doesn't actually exist right there. It gets really, 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 really close, but it doesn't quite make it there. But it does exist here. So the vertical line is hitting only one time. This is actually a more vertical line doing showing the same thing. So that is where it hits. This is not considered a hit because that circle means it's not actually existing right there. So the purple graph is a function as well. Vertical line test. Let's go ahead and put that on there for you. When you have data given to you graphically, you can quickly and easily, you don't even have to write it, you can just look at it. Will a vertical line hit that function graph more than one time? Yes, then it's not a function. No, then it is a function. Kind of an inverse relationship right there. So, to summarize, a domain is the question. The set of data that is the question. That always comes first in the ordered pair. The range is the set of answers. That always comes second in the ordered pair. X's are the domain, Y's are the range. Both the domain and range, X's and Y's, go alphabetical in ordered pairs. A function is a relation with no duplicates in the domain. Or, if it's given to you graphically, a function is a graph that is hit no more than once in a vertical line test. Thank you.